Hello mathematicians! Today we are talking about ellipses. So these are ellipses, they're kind of oval shaped. The ellipse on the left has the major axis going this way. Label this as our major axis. That's where the ellipse is longer. And the skinnier part of the ellipse is the minor axis. So on our other ellipse, the major axis is going up and down. And the minor axis is going side to side. Alright, now on an ellipse, we have some vertices. So the main vertices are these points that are at the end of the major axis. Right here, right here. These are our vertices. Just one is called a vertex. So on our other ellipse, the vertices are here and here. And then these points on the minor axis are called the co-vertices. And just like the other day when we were working on parabolas, we have our foci, or just one is called a focus. And that is just inside of the vertices. Alright, so that is all of the parts of our ellipse. Now, standard form of an ellipse is x squared over a squared plus y squared over b squared equals 1, where a is always greater than b. That's really important. A is always greater than b. So this equation is the standard form of this ellipse, and the standard form of the other ellipse is similar, just that we have x squared over b squared plus y squared over a squared equals 1. Alright, so now we need to label the various parts of our ellipse that matches the standard form. So the vertex on this side is a comma 0, the a coming from here, and the other vertex is negative a comma 0, since on the other side. And same for this one. On top it's 0 comma a, on the bottom 0 comma negative a, since it's on the y-axis instead of the x-axis. Alright, the b goes with the co-vertices. So here we will have 0 comma b, and then down here we'll have 0 comma negative b. And similarly with the other ellipse, over here we have b comma 0, here we have negative b comma 0. And then our foci have another variable, c. We'll talk about how to get c later. So foci is negative c comma 0 and c comma 0 on this ellipse. And this ellipse we have 0 comma c, 0 comma negative c. So you might need to pause for a moment to copy this down. Alright, and then we can fill in our chart with all of our lovely information. So our first ellipse has its major axis horizontal, so we'll start with that one. horizontal. And our standard form equation was x squared over a squared plus y squared over b squared equals 1. All right, we haven't talked about the length of this major axis yet. So the length for the horizontal is going to be 2 times a. So a is kind of like its radius on the major axis. And similarly, if you needed the length of the minor axis, that would be 2 times b. That's the same for our other ellipse as well. All right, continuing with our horizontal ellipse, the vertices are at plus or minus a comma 0 from here. Our co-vertices are at 0 comma plus or minus b from here. And our foci are at plus or minus c comma 0 from here. All right, and then our other ellipse is called a vertical ellipse because it's long going up and down. All right, so again, our equation is x squared over b squared plus y squared over a squared equals 1. And again, the length of the major axis is 2 times a. And then everything's just kind of flipped around. So our vertices are 0 comma plus or minus a. Our co-vertices are plus or minus b comma 0. And our foci are 0 comma plus or minus c. Now, we didn't have a c up in any of our equations, but you are going to need to find that so that you can find the foci. So c squared equals a squared minus b squared, or you can just say that c equals the square root of a squared minus b squared. All right, now we have an example. So flip your paper over or get a piece of graph paper for this example. We need to graph the ellipse x squared over 16 plus y squared over 25 equals 1. So first we need to decide, is this going to be horizontal or vertical? So remembering that a is always greater than b, we can also say that a squared is always greater than b squared. So looking up at what they gave us, we know that on the bottom we have 16 and 25. 25 is bigger, so that means that 25 is a squared and 16 is b squared. So we can solve for a and b. So just take the square root of both sides. A equals 5, b equals 4. From there we can solve for c. So we know c equals the square root of a squared minus b squared. Plug those in. 25 minus 16 give us the square root of 4, which we know equals 2. So c equals 2. Then we can find our vertices, our co-vertices, and our foci before we graph. So our vertices are, since it is, we never decided if it was horizontal or vertical. So since our bigger number was over here, that was a, looking back at our handy dandy chart, this is the one that has a under the y, so it will be vertical. So then, looking at our chart again, we Now the vertical major axis, the vertices are going to be 0, comma A. A was 5, and 0, comma negative A. Then our co-vertices are going to be B, comma 0. B was 4, and negative B, comma 0. And our foci were 0, comma C. C was 2. 0, comma negative C. All right, so then we can go ahead and graph. So our ellipses always have a center at 0 for what we're working on right now. So 0, comma 5, 0, up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Co-vertices 1, 2, 3, 4. And we just connect the dots. And then our foci are at 0, 2, 0, negative 2. Then if you need to know the length of the major axis, that's 2 times A, so that would give us 10. Length of the minor axis should be 2 times B, so 2 times 4 gives us 8. Or you could just count either direction. And that is how we graph an ellipse. If you need any more help on this section, 11.1 in your book is really helpful. And that wraps up ellipses.